You know, it's the force that's charging your phone right now, heating your lunch, and somehow beaming this explainer straight to your screen. It is everywhere, but it's completely invisible. We're talking about electromagnetism. And let's be real, it can feel, well, a little intimidating. But what if you could not just understand it, but really conquer it?
So how do you actually do that? That's the big question we're going to tackle. In this explainer, we're going to break down a complete toolkit, a step-by-step strategy to transform electromagnetism from this really tough subject into a fascinating new way to see the entire world.
All right, so if you're going on a journey into an invisible world, where do you even start? Well, you need a compass. And when it comes to electromagnetism, your compass is visualization.
We're talking about forces you just can't see, right? Things like electric fields, magnetic fields, and potential. The biggest hurdle for so many people is that these ideas are purely abstract. So the key is to start by building a picture in your mind. Imagine these fields as lines of force, kind of radiating out or swirling around. Making them tangible in your imagination, that is the crucial first step.
And look, this isn't just some abstract theory. You have been seeing these forces your whole life. I mean, think about the raw power of lightning. That's just a massive electric discharge. Or that simple, undeniable pull you feel between the north and south poles of a magnet. Even your microwave oven. It uses electromagnetic waves to heat up your food. When you connect the theory to these real-world things, it just clicks.
And you don't have to rely on just your imagination. There are some fantastic free simulation tools out there, like PhET from the University of Colorado. You can literally drag charges around and watch the electric field lines change in real time. It's like having electromagnetic superpowers right on your computer. It makes the invisible visible.
Okay, so once you can visualize this world, you're going to need a map to navigate it with some precision. And that map is mathematics. Now, I know what some of you are thinking. Oh no, not math, but just stick with me here.
Here is the most important thing you need to remember. Don't get bogged down in the math just for the sake of math. The numbers and symbols, they're just a language. They're a language used to describe the physical reality you've already started to visualize. The goal isn't just to solve equations, it's to understand what those equations are actually telling you about the world.
And right at the heart of this map, you'll find Maxwell's equations. The best way to think about these four equations is as the fundamental rules of the game. They are basically the constitution of the electromagnetic world, and they elegantly describe almost everything about how electricity and magnetism work together.
So let's just break them down real quick. First, Gauss's law for electricity. It just tells us that electric charges create electric fields. Simple enough. Then Gauss's law for magnetism says there are no magnetic monopoles, meaning you can't have a north pole without a south pole. Faraday's law is amazing. It shows that a changing magnetic field actually creates an electric field. And finally, Ampere's law tells us that moving charges, currents, create magnetic fields. That's it. Those are the four core ideas.
Now, to really read our map, we just need two more concepts. The first one is divergence. Forget the complicated math for just a second and think about what it means physically. Divergence tells you if a field is spreading out from a point, kind of like light from a light bulb, or if it's converging into it. Is there a source or is there a sink? That's what divergence tells you.
The second concept is curl, and again, the name pretty much gives it away. It describes how much a field is swirling or rotating around a point, like water going down a drain. When you start to understand divergence and curl as just spreading out and swirling, the equations suddenly feel a whole lot more intuitive. Okay, you've got your compass to see the world, and you've got your map to understand it. So what's next? Well, it's time to get your hands dirty with your field kit. This is all about learning by doing.
Theory is one thing, but honestly, the best way to make these concepts concrete is to build something. You can start with two incredibly simple but really powerful projects. First, building a basic circuit, and second, making your own electromagnet with just a coil of wire.
Let's just focus on the circuit for a second. When you get a breadboard, an LED, and a resistor, you're not just connecting wires. You're physically experiencing these concepts. You can actually see the LED light up, which shows you current flow. You can add a resistor and see the light dim, directly observing what it does. This is Ohm's law, not as some formula in a book, but as a real, tangible thing happening right in front of you. So you've got your compass, your map, and your field kit. There's just one more thing you need for a successful journey: your expedition team. You do not have to explore this world alone. Trying to study complex topics alone can be so frustrating. You hit a wall and you just get stuck. But when you work with other people, the whole dynamic shifts. Studying together helps clarify your own thoughts, it exposes you to totally new ways of thinking, and, maybe most importantly, it reveals what you don't know. The moment you try to explain a concept to someone else, that is the ultimate test of whether you really get it.
So, how do you find your team? It can be as simple as forming a study group with some classmates, or you can actively try to teach the concepts to a friend. And hey, don't forget the global community. Websites like Reddit have forums like r/physics where you can ask questions and discuss ideas with people from all over the world. Ultimately, when you bring all of these elements together, something just clicks. Your whole perspective shifts. Electromagnetism stops being this impossible, abstract subject from a textbook. It becomes a powerful lens, a truly fascinating new way to understand the unseen forces that are shaping the world all around us. So there it is, your complete explorer's toolkit. You've got your compass to visualize the invisible, your map to understand the rules of this new world, your field kit to actually interact with it directly, and your expedition team so you can share the journey.
With these tools in hand, the world doesn't just look the same anymore. You start to see the fields, the forces, and the waves. So the only question left is, now that you know what to look for, how do you see the world around you?